Hi, I'm Matthew Whitley from Middlebury College, and I'm making this tutorial on behalf of Nova Vermont. This is the third video of four, and I'll be explaining in depth the layers in the Vermont Agency of Natural Resources Atlas that will help you in flood risk assessment and management. The most important folder under the Rivers Management folder here is the SGAT-FIT layers. Make sure you turn it on so you can see the different layers beneath of it. So, debris jams and beaver dams are important layers because they show where the river has been blocked. Over here, by Beth and Bruce's farm on the Winooski River, the river is very wide. The river is very wide, so it's not like a beaver is going to come over and dam it. But on smaller streams and other tributaries, they can contribute a lot to flooding, as if they, because they back up with water and impede the flow. So over here, on the Huntington River, beaver dams and debris jams could show up. One thing about this atlas that is slightly annoying is that all of these SGAT-FIT layers are scale dependent, so you have to be zoomed in close enough to the landscape for them to show up. For instance, at this scale, you can't see that there's a beaver dam on the Huntington River, but when you zoom in far enough, it'll show up. So just the difference between this and this will be the difference between a visible and an invisible beaver dam or debris flow. The next set of layers that's important is the dredging folder. All commercial mining, dredging, and gravel mining all are very important because they take gravel and sediment out of the river, which is important because it deepens the channel of the river. Deeper channels have a huge impact on how the water flows because it channels the river downstream and makes the water move faster. Faster water will have less of a chance to overflow the banks of the river, which is an important process to dissipate the power and the energy of the river. So when the channel is deeper, the water moves faster, which in turn picks up more sediment and deepens the channel of the river, making the banks deeper and harder to overflow. Thus, it has sort of a negative feedback loop and compounds the problem. So, areas like this, upstream, have mining where they're probably taking gravel out for construction, and this is a sign that the river is going to move faster because it's deeper and has less of a slowing effect on the water. So this dredging folder is important to look for, especially upstream of your property. The next important folder is the migration folder. Here we see avulsion, braiding, and migration as the top three. Let's turn the folder on. Avulsion is when the river takes part of the riverbank and carries it downstream, which shows instability and the places the river is fighting back against the land. This can show us where the river wants to flow. Braiding happens when the river weaves through shallow gravel pits, creating multiple channels. This happens a lot in the Arctic, but also on shallow floodplains. It can be important to flooding when one or more of the branches is blocked somehow, putting strain on the other branches and other braids of the braid, making the other sections of the braid carry more water. Finally, migration shows where the river has wandered, moving towards one bank or the other. This also shows instability of the path over the river. This shows us the dynamic aspect of rivers. In this case, the Agency of Natural Resources maybe should have shown the river next to Ruth and Beth's property with a little bit of migration, because if we zoom out, we can see that due to these oxbows in the landscape, we can see that the river used to flow this way and meander more, but somehow it's migrated to the south of 89, and my bet is that the construction of 89 has very much impeded the flow of the river, and is one of the reasons that these old oxbows are only vestiges in the landscape. Oh, take that off. Sorry. Migration, take off. Let's close that. The next important layer is probably stormwater input. And this is really important because this layer shows inputs from man-made drainage systems collecting rainwater or stormwater from impervious surfaces around. Um, so this essentially adds water that would be absorbed by by pervious surfaces, grass or trees or something, but isn't because we've built up the landscape around, and then adds that to the river system. So if we look upstream, we can see a couple, um, and actually here there's two that are channeling water from the roads and the other impermeable surfaces around into the river and adding them to the water. This is important because if they're upstream, they can add a significant amount of water to the river system in flooding times. Also important is this mass failure layer. Mass failure shows where the sides of the river have given way and fallen into the river, also showing weakness. And this is happening because the river is undercutting the bank, which also shows that the river wants to flow in the direction of this mass failure. Ooh, you have to, oh no, that's string causings. And remember to have not only the box checked of the thing you want to see, but also the boxes of the folders above it, because if I turned this off, then I wouldn't see any of the things, even if they are checked. So make sure that your hierarchy is checked all the way up to the top. Next would be armoring or revetment. Here, the next one. And you can see this is divided into the left bank and the right bank. And so here we can see that the right bank has been armored somehow. And examples of these would be riprap, or any cement feature holding the river at bay from the land. And these are important aspects to look at in the landscape because these are areas that us humans have recognized that are weak and have strengthened them. Because we know that the water wants to flow there. So here, probably this right bank has been armored to keep the integrity of this railroad. Because if they didn't armor this side of the river here, the river would probably undercut this railroad and would create big problems for the infrastructure. So that's an important tab to look at. Another two tabs that are also interesting is this buffer less than 25 meters, which will also show left and right banks, and development. And both of these tabs show the stretches of the river that people have been encroaching on, and where development has come within 25 feet of the river. This really emphasizes the struggle between people and the river clearly. Both the people and the river are competing to occupy the same place. And these areas that have this you see here, this Cochrane Road is probably too close to the river and is closer than it should be. And really, this shows the struggle between the river and the built landscape. And see, if we zoom out, it'll disappear, sadly. But actually, this whole encroachment folder here, this little subfolder, uh, will also show places where humans and the river are competing for the same space, either through berms or roads or improved paths or railroads. Back here, this is a good example of where the railroad is encroaching on the river. Um, finally, oh, not finally, actually, second to finally, we can see here erosion on both sides of the bank. This is also an important layer because it shows where the river is actively fighting back against the humans. Um, it shows that the river especially wants to go um, in this direction and is eating away as much as it can to get there. Um, and this happens a lot more. Erosion and encroachment happen a lot more in areas of the river that have been straightened. So maybe this layer, straightening, is one of the most important layers to look at because it'll show all along the river where humans have straightened the river. And straightening is a big impediment to natural geomorphic processes because it shows where we've actually changed the river. Naturally, an unimpeded river will move and wander and meander to dissipate the energy and power of the river. And in times of high distress, the river will actually overflow its banks to flood floodplains in order to dissipate more energy. However, when we humans straighten the river, we prevent it from dispersing its energy um, and therefore create problems for ourselves. When a river is straightened, it will channel the water straight, which will empower the water actually, and move and allow it to pick up speed, moving in a very direct path. Like I said earlier, this will increase, in turn, create a deeper, steeper banked river that picks up more sediment, reinforcing a cycle. So looking at our landscape, we can see the Winooski has been very much straightened. In fact, probably from Richmond all the way to Montpelier, if not, Waterbury, at least. It's been very much straightened, and it's a little annoying that this layer is scale dependent because I bet if you zoomed in on any place along this river, you would see that that the river's been straightened. And in fact, it is along this whole stretch. Well, maybe not there, but in general, along this whole stretch, it's been straightened. And that's probably mainly due to 89, because 89 is a big piece of infrastructure that is expensive but also important, so we want to defend it either through armoring or revetment or changing the course of the river. Um, so if you zoom out even more, you can see after Richmond, the water will actually start to the river starts to meander, and even over here, it wanders back on itself closer to Burlington. So lucky for everybody in Burlington, the Winooski hasn't been straightened straight um, to the lake here, because that would actually cause a lot of problems in the built-up area of the city. So anyway, let's go back to Beth and Bruce's property. The final layers I wanted to show you are the wetlands layer and the geologic folder of layers. So to find these, we can turn off the river management and go into watershed protection. And under watershed protection, we can find this wetlands BSWI. And these are rough boundaries of the wetlands, so they're not very exact, but they are important to look at. because wetlands are immensely important to flood risk, because the primary purpose of wetlands is to allow the river to flood them. The species that live in these areas can survive, even a foot of water covering the ground, and sometimes they actually need it. And thus, wetlands allow the river to dissipate a lot of its energy and are invaluable to flood mitigation. If wetlands are on your property, they will help you when the force of the river comes knocking at your door. So for this and many other reasons, wetlands should be conserved and protected. And lastly, the geology folder of um, of layers. A lot of these probably won't pertain to you. The superficial geology isn't that important, and neither is the bedrock. But um, the most useful to farmers are the soils layers, and these will actually give you all of the soil attributes and names, and as well as the prime agricultural soils and hydric soils. However, keep in mind that these are only estimates and are not completely accurate, but they do give a general sense of the soil around. Um, However, if you want a soil survey that is completely accurate, you should do it yourself or hire somebody that can and is qualified. So, in the end, all of these layers that I talked about today are very important to assessing flood risks in the landscape and can be really valuable tools to help you plan and manage for flooding.